Hey guys, what's up? Today we've got a differential equation, first order differential equation, non-homogeneous, that we're going to solve using Laplace transforms. So to solve a differential equation using Laplace transforms, there are a couple of things that we need to know. We're going to set the Laplace transform of y of t, which is the solution to the equation. Set that Laplace transform to be capital Y of s. Then there's a theorem that tells us that the Laplace transform of y prime of t would be equal to s y of s minus y of 0. All right, so once we have that information, we can solve the Laplace transform, or we can solve the differential equation using Laplace transforms. The first step is to take the Laplace transform of both sides of the differential equation. So Laplace transform of the left side is going to be Laplace transform of y prime plus 6y equals the Laplace transform on the right side, which is Laplace of e to the 4t. So Laplace transform on the left side is going to be s y of s minus y of 0 plus 6y of s equals, and we have to recall, what is the Laplace transform of e to the 4t? That's 1 over s minus 4. So just simplify this a little bit. We get s y of s minus y of 0, which is 2, plus 6y of s equals 1 over s minus 4. Now what we're going to do is we're going to isolate y of s. So now step 2, isolate y of s, capital Y of s. So capital Y of s is the Laplace transform of the solution. So if we can isolate y of s and then take the inverse transform, then we'll get back to y of t. So isolate y of s. So on the left, what we can do is we can factor out y of s, and that'll leave s plus 6. If we move that minus 2 to the right hand side, we get positive 2 over here, plus 1 over s minus 4. So we've almost got it. Now all we need to do is divide through by s plus 6. So then y of s will be equal to 2 over s plus 6 plus 1 over s plus 6 s minus 4. So the third step is take Laplace inverse to get y of t. All right, so y of t is going to equal Laplace inverse of 2 over s plus 6 plus 1 over s plus 6 s minus 4. All right, so the first one, that one's pretty easy to take the Laplace inverse transform of. The first one is just going to be 2 e to the negative 6t. However, the second one, we need to use partial fraction decomposition. So we'll say plus the Laplace inverse. So if you don't remember how to do this, check out my video on the strategy for partial fraction decomposition when dealing with Laplace transforms. So what we're going to do is we're going to separately work out the partial fraction decomposition for this function 1 over s plus 6 s minus 4. All right, so to break up these partial fractions, to break up this function here, we use these partial fractions. And the first step we're going to do is clear the denominator. So clear the denominator by multiplying both sides by this denominator. 1 equals s plus 6 times s minus 4 times these two terms, a over s plus 6 and then b over s minus 4. So then that's going to leave us with 1 equals a times s minus 4 plus b times s plus 6. Now there are a couple of strategies here when you do partial fractions like this. I like to pick some specific values of s to plug in. So pick strategic values of s to plug in to kind of cancel out these terms and solve for one of the variables. So I would pick s equals 4. So if s equals 4, then I get 1 equals a times 0 plus b times 10. And that tells me automatically that b has to be 1 over 10. And then I would pick maybe s equals negative 6. And that would tell me that. So I go back up here, go to this first equation right here, and I plug in s equals negative 6. So I would get 1 equals a times negative 10 plus b times 0. And that would tell me that a is equal to negative 1 over 10. Now some people use the cover-up strategy for this problem, these partial fractions, and that's perfectly okay, but this strategy is going to work in general because eventually you'll get a system of equations. Even if you can't cancel out all the terms like this, you'll get a system of equations that you can just use, and you can solve it by elimination or whatever, and you can get the factors that way. So we've got our coefficients now, so this a is negative 1 over 10, and this b now is 1 over 10. So we can go back and we can plug that into our partial fraction decomposition inside our Laplace transform. All right, so now we're looking at taking the inverse Laplace of, well, this is 2e to the negative 6t still, plus inverse Laplace. A, we said, was negative 1 over 10, 1 over s plus 6, plus b, we said, is 1 over 10 times 1 over s minus 4. Now we can take the inverse Laplace transform. This is just going to be an exponential. This is just going to be an exponential. Keep those constants. We can pull those out. So this is going to be 2e to the negative 6t minus 1 over 10 e to the negative 6t plus 1 over 10 e to the 4t. Now just combine those two terms with e to the negative 6t, and we're going to get, see, 2 times 10 would be 20. 20 minus 1 is 19 over 10 e to the negative 6t plus 1 over 10 e to the 4t. And that is our solution, y of t, to this differential equation.